Hi, in this video, we're going to talk about the TCP connection establishment known as the three-way handshake. Okay, so TCP, it's connection oriented. When two hosts communicate using TCP, a connection is established before any data can be exchanged. Okay, to establish connection, the hosts use something known as a three-way handshake involving the Syn and ACK control bits in the TCP header. We're going to take a look at this in detail. Okay, so what does it do? It establishes that the destination device is present on the network, so the client makes sure the destination is there, verifies that the destination device has an active service and is willing to accept requests on this port number from the client. Okay, and it's just an agreement between the client and the server that they're going to form this communication. This is important because both the client and the destination, the server in this case, must allocate resources to keep track of this connection. Okay. This can be much more resource intensive on the server that may have to actually maintain some kind of state with multiple clients. And what is all this state? Well, we'll see later that this all has to do with reliability, flow control, and congestion control. But first, we need to establish the connection, that both sides are willing to establish this connection and maintain some sort of state so that the information can be sent and received reliably. Okay, so TCP uses, in the control field, some flags. Okay. These fields are known as flags, are each 1 bit long and can contain only one of two values, a 0 or a 1. Either it's off or it's on. Okay. All right, so let's take a look at these 6 flags. We have the urgent pointer field, the acknowledgement field, the push function, the reset connection, the synchronized sequence number, and the finished, no more data from sender. And as you can see, we have 3 of those bold, ACK, Syn, and Fin flags, and those are the 3 that we're going to be focusing on. Of course, these other ones are very important, but they're beyond the scope of at least the videos I have for right now. Okay, as far as the three-way handshake, we're going to focus on the ACK and the Syn flags. Okay, so the client initiates the connection. Okay, it sends a TCP segment with an initial sequence number. So you can see that's highlighted, 32-bit sequence number. And the Syn flag set to 1, meaning that this is the initial sequence number. The other flags, the ACK, Fin, etc., are all set to 0. The sequence number is a random number. This is to prevent any TCP sequence prediction attacks. There's several attacks that can occur when you actually can predict what the sender's sequence number is, the initial sequence number. Okay, we won't go into that here, but notice that these do not start at 0 or at 1. They're usually some large random number. Okay, all right. Let's just go back here. So if we can see here in step 1, the Syn flag is set to 1, and the sequence number, in this case, we're going to make it 100 is the sequence number. The Syn flag set to 1. Okay, step 2. The server is going to reply with what we call a Syn ACK. Okay, so first of all, the server receives the client's initial sequence number and is going to reply with an acknowledgement number. Okay, the acknowledgement number is going to consist of whatever the host's initial sequence number was, which was 100 from the host. Remember, host A here, the client, had an initial sequence number of 100. So the acknowledgement number, okay, the acknowledgement number is going to be 101. One more, let me here we go. So the sequence number was 100. The acknowledgement number is going to be 101. One more plus 1 of the initial sequence number. Okay. The other thing it's going to do is set its own sequence number, which is 300 in this case. Okay. All right, so let's continue with this. The acknowledgement number, by the way, is known as an expectational acknowledgement. The next byte this host expects to receive. We'll talk more about this when we talk about how sequence numbers and acknowledgement numbers are used to ensure reliability and retransmit any packet loss. We'll look at that in later videos. Okay, the ACKs are sent as expectational acknowledgement. So that's why it's one more than the sequence number. Now, the server in this case is going to reply with its own initial sequence number. TCP communications is usually bidirectional. We're both sending and receiving information from each other. So information sent from host B, the server in this case, is going to have its own initial sequence number, which is also a random value. Okay, and as we can see here, that sequence number is 300. Okay, both the reply flag, the reply is in step 2, both flags, the Syn flag and ACK flag, both of these flags are set to 1. The Syn flag means that this is an initial sequence number. The ACK flag means that there's an acknowledgement of a previous sequence number. Okay, and the third step is the client acknowledging that it received the Syn ACK from the server. So if you can see here, the client receives an ACK and recognizes that it's its initial sequence number plus 1. The ACK consists of the servers, and the ACK consists of the initial sequence number plus 1 plus 1. We'll take a look at this more in just a moment. I'm going to highlight all this. Okay, so let's take a look. The initial sequence number of the client was 100. Okay, so it had sent this, and the ACK coming back is 101. That's what it expects to receive. So it sees the ACK coming back of 101. It says, hey, that's what I expected. I expected to see that. Okay, the server sent its own sequence number of 300. Okay, so the client's going to acknowledge the server's sequence number of 300 with an acknowledgement number of its own 301. Okay, so it will send with the ACK bit set saying that I've got an acknowledgement number for you. I'm acknowledging your sequence number of 300. This is where we get the terms Syn ACK, kind of got that covered there, ACK. So three-way handshake really consists of Syn ACK, ACK. All right, let's take a look at what this looks like in Wireshark, for example. Okay, well, before we get there, let me show you another example. PC1 requests the client-server communication session. Okay, it comes, the client, it initiates the connection. Okay, sequence number, in this case, initial sequence number 100, and so it has its control flag, the Syn flag is set to 1. Sends that. The server receives this. Server says, okay, I need to acknowledge your sequence number and then send my own sequence number. So it's going to send it's going to acknowledge the sequence number of PC1 with an acknowledgement of 101 there in blue. And then it's going to create its own sequence number of 300. Okay? Because it has its own sequence number, initial sequence number, the Syn flag is set. Because it's acknowledging something sent from PC1, it has the ACK flag set. So there's the Syn ACK. Okay. PC1, it's going to acknowledge that it received the initial sequence number from the server by sending an acknowledgement. The acknowledgement will be 301, one more than the initial sequence number of the server. Okay. Now, notice that the sequence number has been incremented by 101. We'll talk more about sequence numbers and acknowledgement numbers when we get into reliability and flow control. Okay. But at this point, now that the session has been established, the connection has been established between the client and server, they're both okay with this. the client can go ahead and send its request for the web page in this case. And you can see this information with HTTP or any TCP connection. Matter of fact, you use Wireshark, you'll see that the first 3 packets sent and received has to do with the handshake. And this is, again, where you can see the Syn ACK, the 3-way handshake. Then, kind of hidden here, the HTTP GET. Okay? So it all starts with TCP. It all starts with that 3-way handshake. Okay? So we can see this here. Here we see the Syn, the initial Syn flag set, the Syn ACK, and the ACK. Love this stuff. You get to see it all, okay? It's not just theory, but you can actually see it in works, how it all operates. Very cool stuff.